Assalamualaikum warahmatullahi wabarakatuh and very good morning. In this video, I would like to present about my undergraduate project, which the title is Xurography Fabrication Technique for Micropump. My name is AFIQ BIN MOHD Romzi, and I'm from UTM. And my supervisor for this project is Dr. Ummikalsom Binti Abidin. For introduction, let's go through a little bit about my background study. So microfluidics is a technology for precise control and manipulation of microscale fluids, especially submicron structure. Microfluidic chip is also known as a lab-on-chip or biochip technology, which it integrates the basic operation units such as sample preparation, reaction, separation and detection in the biological, chemical and medical analysis process into a micron scale chip to automatically complete an entire analysis process. It is used to microfilm a large laboratory system on a glass or plastic substrates, thereby replicating the entire process of complicated biological and chemical reactions and completing experiments quickly and automatically. A microfluidics paper-based analytical device shown an increase of its applications and demands since it was first introduced in 2007 in the application of bioassay studies by using patent paper by Martinez et al. In 2010. The microfluidics paper-based analytical device brings many advantages and has a higher demand due to its inexpensive, works with low volume of samples, able to self-power due to its interwoven cellulose fiber, able to store reagents, user and manufacturer friendly, and a portable compact device, according to Abdullahi Al-Akhdam et al. In 2018. It emerged as a promising alternative to the conventional microfluidic device for disease diagnostics, drug analysis, environmental monitoring, and food quality control, offering affordable, portable, and biodegradable analytical device. There are three objectives for this project, which are to fabricate a simple micropump with a trapping chamber design using xurography and thermal lamination process. Second, to characterize the fabrication quality of simple micropump. And the last one is to characterize deionized water flow through a simple micropump. Let's go to the literature review. So for the first one, we will look to porous media properties. So the first one is permeability. Permeability is to indicate and quantify the fluid flow through a porous medium, according to Hummel et al. In 2018. Essential properties for permeability is porosity and specific area, according to Undergraduates et al. In 2015. While for porosity, porosity depends on the texture and structure of porous media by measuring its void or vacant space, according to Parr et al. In 2016. The essential properties for porosity is total volume of material and volume of vacant space. To indicate about permeability and porosity, we can see this example, which is green ball has high porosity and permeability compared to the mixed ball. Next, for experimental analysis of porosity and permeability in press paper, which is in this study I will using xurography and thermal lamination process. So according to Parr et al. In 2016, porous network of paper collapse when it is exposed to applied pressure. So as we can see, decrease in pore size and thickness affects the permeability of paper. Next, as we can see, wicking in paper strips under consideration of liquid absorption capacity. According to Sirikul et al. In 2020, the dependence of fluidic resistance on the material characteristics, which is lamination, may reduce the thickness of paper strip and provides a larger fluidic resistance. Fabrication, flow control and applications of microfluidic paper-based analytical device. As we can see, flow rate controlled by the changing of fluid channel geometry according to Lim et al. In 2018. Variation in channel length, width or flow path can affect the flow velocity. Next, the last one, which is self-powered or infusion microfluidic pump for ex vivo drug delivery. As we can see from the comparison below, flow rate as a function of filter paper characteristics according to Rosso et al. In 2018. So, larger particle retention gives higher flow rate, which is the larger particle retention for Workman grade 4 will have a higher flow rate compared to the Workman grade 40. For the next part, we will move into the methodology of this undergraduate project. So this is the flow chart of this project. I start my project with the investigation of simple micropump studies from the literature review and theoretical studies. Then to achieve the first objective, I will fabricate the micropump using xurography and lamination technique. I patterning the PVC layers using digital cutter, cutting filter paper using digital cutter, and also assembly the micropump layers using lamination process. So to achieve my second objective, I will study about the characteristic of the fabricated micropump, and to achieve my last objective, I will set up the experimental rig and testing the volumetric flow rate data collection of the micropump using the ionized water, data analysis on flow rate measurement and effect of the trapping chamber design, and the last one I will make a conclusion and recommendation. The material for this project will be using Workman Ashless filter paper grade 40, 41 and 42, which is W40, W41 and W42, distilled water or the ionized water and food coloring, PVC rigid sheet and laminating film. So this is the sample example properties of W42 filter paper from the supplier's catalogue. The equipment for this project will be using digital tabletop craft cutter, which is Silhouette Cameo 4 Plus machine, laminator machine daily, petri dish, shrink or pipette, digital clock with humidity and temperature features, digital camera, which is my phone, stopwatch, pencil, ruler and scissor. Next, we will move into the fabrication of the simple liquid channel. The first one, I will prepare drawing of the liquid channel in SolidWorks, then cut the PVC rigid sheet using digital cutter. Next, peel off the pattern from the cutting mat, remove residuals and check the quality. Cut filter paper using scissor by using the detailed specifications. And the last one, sandwich the liquid channel and filter paper between laminating film. Next, for the experimental setup, first I will drop fixed volume of colored distilled or deionized water at the inlet of the liquid channel. Next, when the liquid reach the starting line, start the stopwatch and record the video of the process. Stop the stopwatch and video recording when the liquid reach the end line. Record the time taken and repeat the experiment for free and confined environment. So next, let's move to results and discussion. The first one will be about the fabrication quality. To evaluate the reliability of the xurography technique, which is involving digital cutting process and thermal laminating process. The dimensions of 4 different micropump sections were measured on 3 samples of cut PVC rigid sheet. Then the findings were compared to the actual designs, which is produced using SolidWorks software, and the Silhouette Cameo 4 Plus can produce various cut patterns with an average of 3.12% of percentage difference with undercutting and overcutting behavior. So as you can see from the graph beside, the average that can produce by the digital cutting machine, the percentage difference is 3.12% from the actual dimension produced in SolidWorks. Next, the results and indication about the influence of different filter paper on sample liquid flow rate. So for grade 41, which is W41, W41 allows more fluid to pass through the pore and has a high absorption rate. The average flow rate for W41 for the 3 samples is 4.2995 micron liter per minute. So the next one is W42, which is grade 42 filter paper, has the lowest average flow rate, which is at 1.6098 micron liter per minute, while grade 40 is 2.1248 micron liter per minute. The new micropump design with a trapping chamber at the sample liquid channel provides higher flow rates than past research, which range from 1.5 to 4.3 micron liter per minute. So lastly, as a conclusion, a simple micropump has been proved to achieve the desired flow rate using different porous material effects in this research. Xurography technique using Silhouette Cameo 4 Plus and thermal lamination process using daily machine can produce various cut patterns with an average of 3.12% percentage difference between measured dimension value and the actual value with undercutting and overcutting behavior. Next, the percentage difference can be acceptable between measured dimension values of actual design using SolidWorks software and cut design produced using Xurography fabrication technique, as it is below 5% according to Idris in 2020. The Xurography and thermal lamination fabrication methods used for this research has been demonstrated to have no leakage on the microchannels. And the last one is the trapping chamber design gives a low resistance effect that reduces the resistance flow and the liquid velocity for cell separation process or cell separation purpose. So I think that's all from me now. Thank you and have a good day everyone. Bye.